Welcome. We're continuing the discussion on Unit 2 on exponential functions, this time through Activity 6, which is solving exponential and logarithmic equations. First, we need to learn how to rewrite this, and I've already kind of teased at some of these things in previous videos, but let's start here. If we have, say, the cube root of 8 equals 2, how can I rewrite that as an exponent? Well, this tells me that 2 cubed equals 8. What about as a logarithm? And this one you've definitely seen in some of my videos before. The 2 is the base. So when we write down our log, we write the 2 here as the base of the log. And then we have an 8. So log base 2 of 8 equals 3. All right, let's try some more examples. For part A, we're given that the cube root of 64 is equal to 4 and 4 cubed equals 64. So this one's almost completely done. We just need to fill in this portion. So I'm going to fill in log base 4 of 64 equals 3. All right, let's do it again for part B. This is 2 to the 5th equals 32. So again, this 2 here became the base. This root is the power, and what was inside of the root is the 32. All right, we can rewrite this as log base 2 of 32 equals 5. Take a moment and try these examples independently. Please pause the video and try these examples independently. All right, now that you've paused your video, your work should match what's on the screen here. So take a moment and double check your work on the screen. If need be, pause the video so you can check your work. Problem 2. Let's find the value of x in each of the following log equations by rewriting the equations in exponential form and then using our knowledge of exponents. We're not going to use technology to solve these problems. So first, for part A, 3 is our base. And the x becomes the exponent, so we know 3 to the x equals 9. 3 to what power equals 9? Yes, it is 2. If you said 2, you are correct, since 3 squared equals 2. So let's do this again. 2 is our base, x here is our exponent, and all of this equals 16. So x has to equal 4. Pause your video and try part C and part D. Now that you've paused your video, your answers for C and D should match. And let's quickly double check our work. So we'll start with C and D. 6 squared indeed equals 36, so that one's correct. 10 to the 1 power is equal to 10. What about A and B? 3 squared equals 9. 2 to the 4th is equal to 16. Next, let's look at this example that you're given typed up in the text, and it's something similar to what I've briefly teased at in previous videos, using logarithms to solve exponential equations. So in the first step, we rewrote this exponential as a logarithm, and then use technology to evaluate. And so if you're using a TI calculator, you need to type in log 15 divided by log 2, and that will give you log base 2 of 15. On GeoGebra, it's super easy. There is a log, and then it has a little box to the box here, and you would just put in the 2 there and the 15 here. All right, so for part 2, we're going to use technology to check that x equals 3.9069 is really a solution to the equation 2 to the x equals 15. I'm using GeoGebra, so please go ahead and take out whatever device you happen to be using GeoGebra on. Even if it's a web browser, go ahead and open that up. So we want to check that this is actually a solution, so we're going to type 2 to the 3.9069 power into our calculator. So that's 2. And in GeoGebra, you see this little icon that looks like a box to a box. That's what we're looking for. That's right here. So go ahead and tap that, and then in the exponent 3.9069. This is approximately 15, so this is indeed a solution to this exponential equation. Problem 3, let's solve the following exponential equations using the equivalent logarithmic form. So let's rewrite this as log base 3 of 10 equals x. So on GeoGebra here, which you should have up already, I'm going to go to this function that's a f of x, and that's here. And I'm typing in this log here with the blank box on the bottom. And on the base, I'm going to put in the number 3, then scroll over with the arrow, and then hit the number 10. And I get x is equal to 2.0959. Let's check our work. 3 to the 2.0959 is equal to approximately 9.9996. Oh, I missed a 9 there. Look at that. Which is about 10. So this is definitely a solution. Now for part B, let's start by rewriting this. So log base 0.5 and then a 0.1 in our parentheses is equal to x. So on your calculator, go ahead and type in log and then type in 0.1. Close your parentheses, hit the division symbol, and then type in log 0.5. And then close the parentheses. And let's go ahead and hit return. To 4 decimal places, we have x is equal to 3.3219. All right, let's solve some more logarithmic equations. And I'm going to skip the calculator part at this point. Please use your calculator independently to get these answers that I'm showing you. I'm only going to cover parts A and C. Please do parts B and D independently. So for part A, let's start by dividing both sides by 4. 2 to the x equals 5. And so we have log base 2 of 5 equals x. And I'm going to leave that for a minute, and we can do the calculator part all at the end. Now for part C, subtract 50 from both sides. You end up with 25 times 1.35 to the x power equals 150. And then you're going to want to divide by 25. So you have 1.35 to the x power is equal to 6. This can be rewritten as log of 1.35 as a base. 6 is equal to x. Now please take a moment, pause this video, and use your calculator to answer both of these and round to 4 decimal places. All right, you should have the following answers. Finally, we can solve logarithmic equations by rewriting things as exponential form. So first step in this example, they rewrote this logarithm as an exponent, and then they used technology to evaluate. As a little aside, 4 to the 5th is the same thing as 2 squared to the 5th power, which is 2 to the 10th, and that's 1024. I always tell students it's not a bad idea to start memorizing powers of 2. And I'm running out of space, so I'll stop there. Basically, all of these numbers are just doubling from the previous, and then that skill comes in handy because then suddenly you can recognize when these come up. Without using a calculator, I can just think, oh, well, that's 1024, or 2 to the 5th, that's easy, that's 32, and that's without a calculator. All right, so let's check that this is actually an equation, a solution to this equation. And for that, let's use our TI graphing calculator. And we want to check that this is a solution. So I'm going to rewrite this as log base 4 of 1024. And I'm going to put this number here into my calculator and see if it indeed equals 5. So on your calculator, we need to use a change of base formula, which is log 1024 in the numerator over log base 4, or excuse me, log 4 in the denominator. And we end up with 5. So that's definitely correct. Problem 3. Let's solve the following logarithmic equations by using the equivalent exponential form. And again, C and D are independent work. So for part A, log base 3 of x equals 6. So this can be written equivalently as 3 to the 6th power equals x. And on our TI, since I already have it up, 3, and then we use the exponent, 6. and you end up with 729. And we can check log base 729 divided by log 3 on our calculator. So log 729, close parentheses, divided by log 3. And you don't actually have to close the parentheses if you're done like this. I'm just going to hit enter, and that gets me 6. So we're done. All right, so now part B. Pause the video and see if you can rewrite this without any help. Now that you've paused your video, you should have rewritten this right here. And so let's use technology again. So 1.25, and then we use this little hat looking thing. And as the exponent, I'm going to put 1.5. Enter. And that gives me x. It's approximately 1.3975. And again, to check our work, and we are going to get something close, but not exact, since I'm rounding to 4 decimal places, and the calculator gave us more than 4 decimal places. You type in log of base 125, 1.3975, which is done through the change of base formula. So log of 1.3975 divided by log of 1.25. I'm pulling up our handy dandy but outdated TI calculator. I get log 1.3975 divided by log of 1.25. And we get about 1.49986. So that's actually really, really close. If I round that to, say, 3 decimal places or less, I'm going to get 1.5. So this is approximately 1.5, which checks out. Finally, let's solve these logarithms by first simplifying, then using the equivalent exponential form. So let's subtract 5 from both sides. Then we have log base 2 of x is equal to 15. So this tells me that 2 to the 15th power equals x. To the 15th is 32,768. All right, so let's do this one. This one looks a little different, part B, and that's because we have to multiply both sides by 3 first. Multiplying by 3 eliminates the 3 in the denominator on the left-hand side, since 3 divided by 3 is equal to 1. So I have log base 2.5 of x is equal to 6, or 2.5 to the 6th power equal to something. So on our calculator, let's see what we get. 2.5 to the 6th. That concludes this video. I hope this was helpful.